you would just start to get it and be able to do it mentally. Maybe, I don't know. Okay, so what do you do with these numbers? Once you have these two numbers, you put them in these spots right here. So 3 and -6. And it actually turns out that it doesn't matter if you write it the other way around. If you put -6 here and 3 here, it's okay. This is just a little visual aid when you're doing this method. You've got your multiplication of the two ends goes here, middle term goes here, and then you try and find those two numbers that multiply to be that and add to be this. Got it? Okay, what do we do with that? Who cares? We did this, now what, right? Like, what's the big deal? All right, so now what we do is we come back over here and we rewrite this, equals x squared. Now check this out. This thing that was 3 terms, right? It was 3 terms. We know how to do 4 terms, don't we? That's 3 terms. We're going to make it 4 terms now. So watch how I make it 4 terms. I'm not going to touch the x squared. I'm not going to touch the -18. The only thing I'm going to adjust is this piece right there. That -3x, I'm going to change it using these two numbers that I found. Don't worry about it, just don't fall when you get up. Okay, so I'm going to use these 2 numbers. So I'm going to write them down. Let me just see if you agree with this. Here's 3, so I'm going to put here plus 3x and then minus 6x. So just make sure that you agree with me that that is the same thing as what's above. Taking a 3x's and subtracting 6x's is still -3x's. Right? So I have just found a way to take -3x and rewrite it in a different way, right? But now I have 4 terms. And if we do grouping on that now, we should be able to get to the answer. All right? We'll do another example. I see some looks of despair and boredom. Okay, so now who's up? Nivini? I've rewritten -3x using this over here because I told you that's how you do this method. And now that we've got this to 1, 2, 3, 4 terms, Nivini, what are we going to do? Yep, split it right here, right after the second term.
And then find the GCF.
Good. Out of these, do you recognize a GCF? I'm going to put the x squared here. I'm going to go ahead and put this parentheses. Do you see a GCF here? Just x, right? So everyone pull an x out. Nivini, if you pull an x out, what's still left in that parenthesis if you pull the x out?
X plus 3.
Good. All right. Now, I'm going to keep going because you're rolling here. Over here, how would you like to do this one? Do you want to pull a GCF or do you want to write that one down and then try and figure out the number? Write it down. Okay, so x plus 3 here, and then you're trying to come up with that number. So what number out there, Nivini, is going to have to be there to work? -6. -6, right there. And when you distribute that through, you get back this. Does that all make sense? Nivini, you're going to just finish it up because you're just rolling now. We should be at the last line, shouldn't we?
Yeah.
Okay, so Nivini, we have x squared. That was the thing we pulled out in the very beginning of the problem. And then, Nivini, how do we rewrite all that crap right there?
So we should do x plus 3.
Yep, x plus 3 in parentheses.
And then you would do the x minus 6.
There you go. Yep, x minus 6. We're done. Now, if you don't believe this, that we did it, if we multiply these two back together, like FOIL, just these two, what should we get back if we FOIL this? We should get this, shouldn't we? I'm going to do it real quick. X squared minus 6x plus 3x minus 18, and these two come down to be that. So this is it. So that method of coming up with that cross and finding two numbers that multiply to do this and add to do this, what it does is it gives you the way you take this -3 and break it down into 2 pieces so you can go grouping. We'll need to do another one, right?
I've got a question.
Yes.
So when you did your, when you did the X,
Yes.
so what if you put -3 and 6?
They wouldn't have added up to be -3. Remember, because this x was -18 here and -3 here, right? Did you ask me if you put -3 and 6? These two don't add up to be -3. They add up to be +3, right? So even though these look like they'd work, they would satisfy this, but they wouldn't satisfy this. Okay?
So anything on top, you're going to multiply it, anything on bottom. Like when you do that method, it's like addition, subtraction.
Wait, say again?
So like when you do the x method,
Uh-huh.
and you put your number on top, that number just has to be multiplied, and then the one on the bottom needs to be like subtract or added.
They need to add together to give you that last number.
Okay.
Okay, so let me come up with one that's a little more challenging. I am willing to bet my all the money I have in my wallet right now that somebody could have done that problem that we just did without doing any of that work. Yes? I don't carry money in my wallet, so all I carry is a card. Sorry. Which is, so if you would have been sitting here at this step right here on a test, I think that was it, right? I do not expect you to go through that whole method if you can just do that on your own without any, like, I just know there are people here that have done enough factoring that realize that this is just x minus 6, x plus 3, and they're just done. Okay, and that's fine on a test. But if it's wrong, it's going to be more wrong than if you did all the work and got it wrong, because you don't have any work to support it. Does that make sense? Mm-hmm. All right, so and the way that people got to that, the people who can do this to this without much work learned a different method called guess and check, which is good, but it takes a lot of time to develop that. You can't just get it overnight. And it's not always foolproof. For example, let's try to do this one. 3x squared. Hold on a second. I got to make sure it works. There we go. So that one might be a little tougher, even for the people who have a method that they do without, you know what I'm saying? Like the people who can do these in their head still might struggle a little bit with this one. All right, you ready to do this? Victor?
Yeah.
You're up.
So you would do the AC method. So
Okay, so you've already said no GCF, right? There's no greatest common factor here.
yeah.
You counted, there's 3 terms. 3 terms means AC method. Now, can you do this one mentally? Or
Not mentally.
could you do the other one before this one mentally?
No.
No? Okay. I mean, some people can. I just, So you need a method then, right? And I'm sure there are people in here that need a method. So let's go with the method, this AC method. By the way, the reason they call this the AC method, I haven't mentioned it to you, is because when you look at this, right here, we call this a quadratic, and this is the form. It's some number in front of x squared plus some number in front of x plus some number by itself. The first step for this method is to multiply this times this, right? Like this number times this number. And that's the A times the C, and that's why they call it the AC method. That's not important. I'm just telling you that's where it comes from, all right? So, Victor, you want to keep going? For this x, you want to tell us what goes in the top and the bottom of this?
So the top would be 6.
6 here because you're multiplying positive 3 times positive 2. And then, Victor, what goes there?
That would go at -7.
-7. So it's always going to be just the number right in front of the x here, all right? Okay. And now you have to come up with 2 numbers that do this. You want to be off the hook? Or you think you got the numbers?
I'm not sure.
Well, go with it. What do you think? Yeah. No? Okay, so let's go through a method then. Let's go through a process. I always like to start out with 1, right? So how could I get 6 from 1? Like multiplying.
Yeah.
1 times 6, right?
Yeah.
So these two would multiply to be 6. But do they add up to be negative 7? No, they add up to be positive 7. So is there another way that I could still get 6 but somehow have these negative?
And you leave them both negative?
What if they're both negative? What if it's negative 1 and negative 6? Do they still multiply to be positive 6? Yes. Do they add up to be negative 7? Yes. Do you see that? Now let me just show some other ones that we could have tried here. 2 and 3, right? This one didn't work. 2 and 3 multiply to be 6, but what do those add up to be? 5. That wouldn't work. I could have gone negative 2 and negative 3. That still multiplies to be positive 6, but what does that add up to be? Negative 5, right? And then are there any numbers that multiply, any other numbers you can think of that multiply to be 6? Nice numbers? That's it, right? 1 and 6, 2 and 3. There's no other way to get 6 easily. You could use fractions and stuff like that, but so there's only one candidate here, right? So that means we're going to put those numbers here, 1, negative 6, and we're ready to roll. Miranda? I don't think Miranda's here. Aaron? Black? Okay, Aaron. How's this going for you? Can you factor already? Could you have gotten this one without doing this? Maybe a little trial and error, no? Maybe. Okay, so this method will work for this. It's longer. Trust me, when I factor, because of course I do this for a living, I can factor that mentally, but you always have to have something to go back to, right? If your method breaks down, you have to have something to resort to if you can't figure out the numbers. So where are we going from here, I guess is what I'm asking.
So you leave the 3x squared,
Leave that alone. What else do you leave alone?
the 2.
2. So you leave the 2 ends alone, all right? So I always like to just kind of do that. And then what?
And then you put the 2 numbers that we just got.
Okay, so I'm going to put just minus 1, minus 6, or
Minus 1.
minus 1x and minus 6x. So you're using these numbers, but remember you have to put an x there so that they create that middle x term. Groupie time? Right after there, right after the second term. Right there, like that. You want to keep going? Yeah? Okay, what do you got on those first 2 terms?
In x.
Just pull an x, okay. What would be left there if you pulled that x?
3x.
Yep, 3x minus 1. All right, the next step. Do you like that way of putting it in there and trying to match it up and make it work? Okay, so we'll put 3x minus 1 here again. And then you have to come up with that.
Negative 2.
-2. What do y'all think? -2? -2 here would give you that. -2 times -2 would give you, -2 times -1 would give you +2. So -2 right here. And I think we're good, right? Just one last step and we're done. Go ahead and finish it. You've taken us this far.
So it's 3x minus 1.
Okay, in parentheses 3x minus 1,
And then x minus 2.
then x minus 2. Bam, we're done. Okay. What do y'all think? Practice, right? Yes?
Does it matter how you write? Like if you write the -1x first or the -6x first?
I'm glad you're asking this question.
Because I had wrote it the other way and then.
Okay, so let me do it. I'm doing a different color. Okay, let's see what happens. So let's say that when you came up with your numbers, you decided to not write it this way. You wrote it -6 here and you wrote -1, right? Okay, so let's see what would happen here. This would now be -6. And this one would be -1, wouldn't it? Okay, so that changes things here. Let me just get rid of this line. So what would our GCF here be now? 3x, right? 3x would be here. So 3x here, what would be left inside? X minus 2, right? X minus 2 would be left if we pulled the 3x out here. And over here, we would need to make it match. So what would need to go out front to make this x turn into negative x and this minus 2 turn into positive 2? Minus 1. And then at that point, since these match, you would write down x minus 2, and then you would write down the 3x minus 1. Right? And these two answers are the same, because multiplication doesn't matter. This order doesn't matter. So it'll work. That's good news, right? That it doesn't matter which way you do this, you can get the same answer? Okay. All right. So there's a bunch of examples here, which we'll work through some of these, but I think we need to move on to just looking at two terms. Okay, so here's a new problem. So when it comes to two terms, I'm just going to write this down here. When it comes to two terms, we can only factor this thing called the difference of squares. I'm lying to you though, you can actually do a difference of cubes, but in this class we won't touch difference of cubes. We're just going to do difference of squares. All right, so when it comes to two terms, the only thing we can ever factor is if we have something squared minus something squared. That's the only thing we'll ever be able to factor if we're down to two terms. All right? So let me give you a formula to do this, and then we'll do some examples. So the formula for this is that if you have something, let's say a squared minus b squared, it will always factor to be a plus b times a minus b. I know a lot of you have seen this before. The formula is very simple to show that it's true. All you'd have to do is expand this. If you did this, just multiply that out, you get back this. The middle terms would cancel. Okay, so that's where the formula comes from. Let's see the formula in action. So as an example, if you wanted to factor x squared minus 4, you would count the terms, right? How many terms do you see? 2, okay. Is this something squared minus something squared? Yes, it just doesn't quite look like it yet. You could look at this as x squared minus 2 squared, right? Right? That's what 4 is. 4 is 2 squared. So now, does it look kind of like this formula up here? So for us looking at this, what's A? A is x, and what's B? 2. So this just becomes x plus 2 times x minus 2. And you can just sit there and do these over and over. I'm going to give you another one. Let's see if you can get this one. How about this one as an example? How about 9 minus x squared? We want to be able to do this without doing a whole lot of work. It should just be a quick answer. So this should turn out to be something times something because it is a difference of squares. What is, Brianna, P? What is the A here for us?
X.
So look at the.
Oh, it's 3.
Yeah, it's backwards, right?
Yeah.
So the A here for us, this is really 3 squared minus x squared. So the A is 3, so I'm going to put 3, and then plus x, and then 3 minus x. If you flip this around, if you make this x plus 3, x minus 3, it's incorrect, all right? It wouldn't be incorrect here, but when you flip that one, it's wrong. So that would be the answer here, all right? Let's do another one. How about 9x squared minus 25y squared? This one's a little trickier. Right, Danny? 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 No Danny? Tanisha, this was a little trickier. Do you see an a squared minus b squared? And if you do, what's the a and what's the b? So this, well, let me put the parentheses here. Do you have a feel for this one? Of what would go in here? Just take a shot at it. No one's gonna care. 9 plus 25. What about the x's and the y's? Okay, so this is a little bit trickier. Let me help. Do you agree that we have something being squared here? The x is being squared?
Yeah.
See, 9 though is not being squared also. So you have to realize that this right here is 3x squared in parentheses. So if I square the 3, what do I get? 9. If I square the x, what do I get? X squared, right? So 3x in parentheses squared, this is our a squared. Make sense? Tanisha, then what would this one be if I rewrote it here? What would be the thing I need here that's squared to give me that? So what do I square to get 25? 5, right? So this would need to be 5, and then I put a y here. So if I square the 5, I get 25. If I square the y, I get y squared. So do y'all see the a and the b? A squared minus b squared. So what does this turn out to be? 3x plus 5y, 3x minus 5y. Do y'all see the difference between this problem and this problem? I mean, there's a little more going on here than there is here, right? Let's do another one. How about this one? Somebody's going to get unlucky right now. Maybe, maybe not. Elizabeth.
So, what do you say? So it's going to be 3x plus 5y,
Uh-huh.
and then it's 3 plus 5y, and then 3x plus 5y.
Okay, so you're seeing the same pattern as you saw here. What's the difference then, Elizabeth, between these two problems?
The minus.
The minus, right? So in this problem, I had something squared minus something squared, right? And on this one, I have something squared plus something squared. And when I started this out just a minute ago, I said factoring two terms, right? I said we can only factor a what? A difference. A difference is subtraction, okay? We can only factor when there's subtraction between two squared terms. If we have addition between two squared terms, we can't factor it. There is no formula for it, all right? So that's why I said you got unlucky, because I gave you kind of a trick problem. But it's important for us to recognize that because there's a plus here, we can't factor it, and therefore what we say at this point is that it is prime, or not factorable, right? If we ever get to a point where it's something squared plus something squared, there is no formula to break it down. If it's a subtraction between them, then we can. All right? All right. Break time? Y'all want to take a break? So,
Say that again, sir, so I can write it down.
okay, so if we have two terms with and they're each squared and there's addition between them, we cannot factor them. It has to be a difference between them. All right, let's take a 10-minute break. It's 12:27. We'll come back at 12:38.